Okay, in this video, I'm going to go through a few problems relating to the normal distribution functions. We're going to do one problem. This first problem deals with the standard normal distribution, and then problems 2 and 3 will address the non-standard normal distribution. You may want to take a couple of moments, pause the video, and read the problem. Okay, so Precision Scientific Instrument Company, they're selling thermometers. And since water freezes at 0 degrees, when water is at its freezing point, the thermometer should read 0 degrees if it's accurate. But maybe there's some slight inaccuracies with the thermometers, and maybe some of them don't say exactly 0 when they're supposed to. Now, let's assume that the mean reading, what it's supposed to be, is 0 degrees with a standard deviation of 1 degree. Now, that tells us precisely that we are working with the standard normal distribution. Anytime we have a mean of 0 and a standard deviation of 1, that means the x values and the z-scores are equal to each other, and we're dealing with the standard version of the normal distribution. Now, assume that readings are normally distributed if one thermometer is randomly selected. Find the probability that at the freezing point of water, the reading is less than 1.27 degrees. All right, well, let's see. Here's our normal distribution, and if the center of the graph, the mean is 0, then 1.27, well, maybe 1.27, we can say about right there. And so when we're looking for the probability that the freezing point is less than 1.27, well, the word probability is interchangeable. It means in the context of these continuous probability distributions, probability is area. And less than 1.27 means we want area to the left, to the left. So here's 1.27, and let's shade the area to the left. This is what we're looking for. What is this area? Okay, it's pretty easy to do with Excel, just one step if you know the function. We're going to use the standard normal distribution function. So on Excel, that is equal norm.s.dist. Okay, that's if we know a z-score, Excel will tell us the area to the left of that z-score. That's what this function does. The z-score is given 1.27, and with continuous probability distributions, we always use 1 or yes or true. We always use the cumulative function. So regardless of which distribution function we're using, the standard, the non-standard, the inverse, we always use the cumulative function. Okay, and that does it, 0.8980. If you are using another method besides Excel, like maybe you're using a table of z-score values and areas that you find online or in a textbook, for example, maybe you're using something like this. Here's just an example of a common layout of a z-score table. The column on the left, the first column on the left is the tenths place, or the first decimal point in your z-score, and the row on top tells you the hundredths place, or the second digit after the decimal point. So we have 1.27, so we go to the 1.2 on the left. That tells us the row. And we go to the 0.07. That tells us the column, and where these two intersect, that is another way. That is another way of finding your answer, and you can see we have the same result on Excel, 0.8980. Okay, but keep in mind, these tables are only used when you have a standard normal distribution. Okay, in problem 2, we don't. The safe load for a certain water taxi was found to be 3,500 pounds, and the mean weight of a passenger was assumed to be 140. Okay, so on a particular day, all the passengers are men, and men have weights that are normally distributed with a mean of 172 pounds, a standard deviation of 2.9 pounds, and when one man is randomly selected, what is the probability he weighs more than 174? More than 174. Okay, well, the mean is 172. Okay, so that's the center of our graph. And we want the probability that he weighs more than 174. Okay, so we could shade the area. Now, more than means above or to the right. So we're looking for this area, the area to the right of 174. Remember, probability is area in the context of these continuous distributions. Okay, now, Excel can't give us that area directly. Excel could only give us area to the left. Now, we could use the rule of complements and say, well, area to the right, that's what we want. Area to the right of 174 should be equal to 1 minus the area to the left. Okay, so Excel could give us this. Excel could give us this green area. So if Excel could give us the green area, we could just subtract that from 1. So area to the left, that's the green. Area to the right, that's the red. We want the red. Excel could give us the green. So we'll do 1 minus the green should equal the red. Okay. So let's see. We no longer have a standard normal distribution. So we're going to drop the dot S. And instead of norm.s, as we used in the last problem, we're just going to use the regular normal distribution function, norm.dist. Okay, so now, since these non-standard normal distributions, every data set has its own mean and its own different standard deviation, so Excel needs that information for this particular problem. So we've got the 172 as the mean, and we've got the 2.9 as the standard deviation. So first comes the x value. That's 174. Then the mean of 172. Then the standard deviation of 2.9. And the cumulative function 1 for yes. Now I'm not going to hit enter yet because this is not what we want. This is the green area. The area to the left. So we'll need to throw in a 1 minus here in the beginning. So 1 minus the area to the left of 174. And we're expecting something less than 50% because that red area is definitely less than half the graph. And yeah, there we go. 0.245 or just about 24.5%. Now this is rounded, so just keep in mind it's not exact. If we add some more decimal places, you'll see that it's rounded to 3 places. Okay, one more. Now, actually, before we go to this problem, let's go actually back to problem 1. In problem 1, we were given a z-score, and we needed to find the area. In problem 2, we were given an x value, and we needed to find the area. So if you're looking for area, that's the normal distribution function, whether it's norm.s.dist or just norm.dist. Depends on if you have an x or a z. Now, problem 3, when designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4. Okay, now what's different about this problem is we don't know the x value. We don't know the x value, but what we do know is the area. Remember, percentage, proportion, probability, area. Okay, so 95%, well, that means the area in here is 0.95, 95% of the area. Okay, and so in this particular problem, we're given the area and we want to find the x value. Remember, in problem 2, we were given the x, we're looking for the area. Now it's the reverse. We're given the area, we're looking for the x. And for that, it's sort of the opposite of what we just did, or the inverse of what we just did. So we use the inverse of the normal distribution function. So that's norm dot INV for inverse. And probability is area to the left. So 0.95. The mean is given. That's the 69.5 inches. And the standard deviation is given as 2.4. Okay, now this should give us an x value, and we're looking, we're expecting a positive x value, obviously, because it's to the right, or not positive. We're expecting an x value well above average. So the average over here in the center is 69.5. So we're definitely expecting an x value, 70s or low 80s. Okay. Yep, 73, about 73, just under 73.5 inches. So since everything in the problem is rounded to 1 decimal place, let's round this to 1 decimal place. It's inches as well. So about 73.4 inches. Okay. Now that about does it. We have 4 functions. We have the 2 for the standard and 2 for the non-standard. We have the equal norm dot s dot dist. This is when we have a z-score. So let's do a different color here. That's when we have a z-score, and Excel is going to tell us the area. We have norm.s.inv for inverse. That's the reverse. That's when we know the area, and we need Excel to tell us the z-score. And then we have the 2, just if you drop the .s, then these are the 2 for the non-standard normal distribution. So there's norm.in, let's do distribution first. Norm.dist, and there's norm.inv for inverse. Okay? The normal distribution function, if we have an x and a mean and a standard deviation, Excel will tell us the area. And with the normal inverse function, if we know the area and the mean and the standard deviation, Excel will tell us the x value. So the third problem we just did was this last one. Okay, that does it for this.